These data were acquired from a standard material, which is ruthenium oxide in the 4+ state. The idea of acquiring these data is to produce a line shape from data that can be used in other peak models. However, in this case you have the potential for carbon 1s to appear at the same place as the ruthenium 3D, so what we need to do is find a way of removing the carbon 1s signal from ruthenium so that we then end up with a line shape that does not depend on the level of contamination of the material. So what we're going to do is use an option that gathers peaks together on the basis of the component index. Now, as it stands, all of these components that were set up have the same component index. We can see visually what peaks have been assigned by ticking the box that says color components using component index. And now you can see all of these have been assigned the same component index because they all have the same color. But we also have a relationship in here that we might want to highlight. So for example, we've got a ruthenium 5/2 and a ruthenium 3/2 peaks within a doublet, and these are related by known proportions in terms of intensity, and we've also introduced an offset between the peaks to add some kind of structure to this peak model. The idea is we could highlight, for example, that this is a 3/2 peak by assigning a different index. So we'll go through, and each one of these 3/2 peaks we will assign a value of 2, so you can now see that these 3/2 peaks are this cluster of blue peaks, and we also have a couple of carbon 1s peaks here, and we'll set these to value of 0. So these peaks now represent the carbon. These are the ruthenium 5/2 peaks, and another display option makes this clear what we're doing by saying combine component index. So when I tick this button and press OK, you can see how the components have all been summed to form envelopes that represent the 5/2, the 3/2 and the carbon 1s. Now what we're interested in is a line shape that corresponds to the full ruthenium 3D doublet. So what we'll do next is we'll set all the 3/2 peaks back to a value of 1, so they have the same component index as the 5/2. So we've now got a total envelope that represents the shape that we think we're going to get from ruthenium 3D doublet from this 4+ state. So to extract the line shape, what we're going to use now is an option on the Test Data tab that also functions on the basis of these component indices. So it says replace by component index. So the first thing I need to do is indicate which component index. So the component that's selected needs to be 1 with the component index 1, because that would be the ruthenium 3D. And when I press this button here, the process data is set to be equal to the sum of all those components that were assigned the component index of 1, that is the ruthenium 3D. And if I copy that and copy the process data only, I get a VAMAS block that contains the ruthenium 3D doublet from the 4+ state. So let us now go back and we'll undo that processing option. So we're back to the original data, and we've ended up with a line shape that can be used in a peak model. And the final step to do would be to use the key string %, less than, greater than, and we'll say it's a line shape for ruthenium 3D. Well, actually it'll be ruthenium 3D, but it'll be RuO2. So this is now a VAMAS block that's in a state where we could use this as a line shape to construct a peak model.